All right, we're going to go through and do all the math that has to do with rectilinear motion. This is actually an AP question every year, where if it's positive, it moves to the right. If it's negative, it moves to the left. If my velocity, which is my first derivative, is 0, what does that mean? It's not moving, right? It's not moving, it's stopping. So when we were talking about this the other day, that would be the restroom break when we're talking about a velocity. So let's go ahead and start this. So where t, because t is going to be positive for all these items, t has to be greater than or equal to 0. So let's start by finding v of t is equal to 3t squared minus 18t plus 15. All right, so what do I do from there? It says determine intervals where the distance is increasing. Thank you. All right, so let's go there. So I'm going to say v of t is equal to 3t squared 18 minus 18. And I'm going to go 0 equals, and I'm going to factor this out. All right, does 3 equal 0? Nope, let's factor that. So 0 equals x what?
T minus 1, T minus 5.
T minus 1, T minus 5. Very good. And so I would say t equals a positive 1 and t equals a positive 5. And from here, what do I use? Very good, number line, number line. So start my number line at 0, 1, 5. I'll need a 6, and I'll need something in between. So let's go 2. So 1 and 5 are the places where my slope is equal to 0. And I just need to plug in to figure out if it's going to be positive or negative in between those things.
Would 0 be positive?
0. Yeah, let me see. I'm going to plug this in so you guys can see. Change up the colors. So this right here is going to be 0. I'd get a negative, right? Negative 1. Over here, get 0. I get negative 5. So 2 negatives make a positive. So all this over here is, so if all that is positive, hello.
Hi, do you have any gloves that we could borrow real quick? Just like working gloves?
Working gloves.
Or
You know what?
gloves?
Huh?
Just gloves.
I have some working gloves. Are you going to get them dirty?
Actually, I don't think so. They shouldn't get dirty.
Okay. Go in there. Go to the table. You know the bucket with the headphones or the headsets on it, like the ear mufflers? Over there. Do you see them? It's on the table. Yes. So the gloves are in that bucket. All right, so we're checking another one now. So I'm going to check 2. If I check 2, this is going to be a positive.
That would be negative.
Positive and negative makes that?
Negative.
So it'd be positive, positive. So place and where that this is increasing. Are you okay, Tree?
I wrote the answer for the parts like different from each other. So like I got the answer for 5C by using the formula hole.
Oh.
By doing 5B, but then I got 5B doing 5C.
Oh. As long as you get it. All right, so it's asking for increasing. So in interval notation, where's my increasing going to start? Where's my interval going to start?
For increasing negative infinity to 1.
Negative infinity.
Thank you.
You're welcome. To where?
To 1.
1.
Parentheses, union, then 5.
Okay, then 5. Infinity. Again, the answer key is actually having different. We just pulled up the answer key, and it is true, but it's weird. So when we get to one of the other parts, this one right here is not going to have a conflict here, but some of the answer keys are including 0 as being positive, and it's including 0 as being negative. But that's not right. So even in the text, it actually said that. So it says from here to here, but you could assume it's going to be the whole thing. But that's what we're going with here. So this is part A. Determine intervals where it is decreasing.
There will be just 1, 5.
Yep. When does the object reverse direction?
X equals 1. That's when it starts changing from positive.
Okay, yep. X equals 5. So x equals 1, x equals 5. Draw a figure that illustrates the motion of the object. So this is probably going to be one of the key things that is going to help you out later on. But it's not the derivative. I use the derivative to find all the motions. I use the derivative to find the motions, but now let's plug it into my position instead. So from 0 to 1. So at 1, how far did we go in the positive direction? Remember, positive direction moves to the right. Negative direction moves to the left. So that's going to be in my original function, I plug in 1. My original function, t3, let me put the original t cubed, no. So 1, -9, 15, 30. I put that there because that's going to be necessary. So we're going to test it. So S of 1. Because that's the place, that's as far right as I go. That's as far as right as I go, and then I change direction. So plug in 1. I should get, let me see, what's that? 18, 9, 10. Feel free to check my math. All right, so that means that from here to here, he went this way 10. Are these in meters? No, it's just whatever my units are. So it goes this way 10. All right, what is our position at 5? Because I changed direction, right? So at t equals 5, let's go ahead and plug that in. Plug that into my position. And I'm going to use a calculator because I don't want to try and do all those. So So right here, my position now goes to negative 22. So that means that right here, I went 10 this way, and from 1 to 5, I end up going this way. Why is it negative 32 if I just said it was 22? Why did I put negative 32 when I said it's 22?
Because
Hey. Oh, excellent.
I want to specifically show them the amazing.
Oh,
chairs.
okay.
Chair back here.
Check the chairs, the benches.
Yeah, no, I'm gonna sit on it.
Here. You want to check out the charcuterie? I mean paddles.
Ooh.
We are selling these. So we have a couple of them that we are selling currently.
it's because of your distance that track.
Yes. Okay, because right here I got my position, my S of 5.
Because you went, let's say like you went up here, you gotta also count going down there.
Yep, there we go. And since I went 10 this way first, I ended up going this way, and I ended up right here at negative 22. So if I end up at negative 22, that means I also had to go this 10 that I started going in the first place. All right, so now what's going to happen at that 5-second mark? Is it? Yeah, it's reversing again, right? So how do I figure that one out? How do I figure that one out? Let's do that again. So there was my negative 22. So S of, what's my other one? 5, and so from that way, so there is, and from that way I change direction. And I just keep going that way from right there on. It's all positive from there. So here's a graph showing what it is. And these are all distance over time. It's my velocities. So I'm plugging them in and actually figuring out where I am at every single point. So I could plug it in and actually go, let's go 7. Why not? So at 7, I'm back at a positive 10. So if you guys look, at 10 seconds, I'm back to where I was at 1 second because I've reversed direction to go this way. And then I went back, I changed direction to go back this way. So 7 puts me back at the same place 1 is.
So it just makes like from the bottom to the top, or from negative.
Yeah, because we're going from here into the negatives to get all the way back up to this.
How do we just like, it's like illustrate it? Do we just do that?
Yeah, this is basically doing what it is.
Okay.
So, and if you notice, I'm using the position function, the S, not the velocity function. The velocity is what I did on my graph right here, and this is my velocity of t. So all this right has to do with my t values. So there are different things that we're looking at, that we're graphing. So the number line is time. Time always goes forward, right? Okay, but my velocity changes directions. So I start by going forward, I ended up going backwards, and then I go forward again. Continue. Yeah? So they have some neat graphs that they do with this, and they actually like circle back and like go back and forth and show them turning around. Yeah.
I was just gonna say, is it okay if you do like a regular actual graph of the position to show that it's moving?
Yes, but we're doing it over time. So you would start here in our position. So if we're doing it like that, so it's going forward from here to here. Okay, so you're saying that it's actually up this way, right? And then goes back down and that. So basically, but in this case, we have to think about it in terms of a car. So in a car, it is where it is at that moment. So you go forward, right? So the car is going to drive forward. It's going to turn around on that same road, come back here, and then it's going to turn back around and go that way. Usually the graph like something like this is what they're looking for. So I have the graph here. I have the graph of the function. The function is like, so it looks complete. So
Oh, you just have to do it
yeah.
here.
So that's what you're saying right there is right here to 1. Okay, 1 we change direction. So it's talking about for distance. So this is your distance here, right?
Yeah.
Okay, and I guess it'd be fine, yeah. But like I said, this is the way that you'll see it, sometimes worded in the information about how it does. All right. There was D. E. When is the velocity of the object increasing, decreasing? Okay. Velocity increasing, decreasing. That has to do with the concavity right there. That's where we're looking. Is it increasing at an increasing rate? Huh?
It's positive, so it would be this and.
Okay, so watch this. I'm going to take a graph now of the first derivative.
It should be decreasing from what? From negative infinity to 1? Because it's positive. Oh no, wait. Yeah, right? Or.
Give me 1 second. I'll show you. So this time we are graphing the derivative, which was 3 squared minus, was it 6? 6 right here?
Minus 9. Wait, what? Oh, you do the derivative?
Yeah, the derivative.
Minus 18.
And plus 15?
Yeah.
Need to grab it here. Okay, right there, I just put the thing there. What is the slope of the derivative at the point where my little marker is? It's 0. Very good. Okay, the slope of the derivative is 0. That has to do where it changes concavity. That's where it's going to be increasing. So, like what we were talking about the other day. So, I want it to be where it's equal to 0. So, this is my derivative. So, but all this right here, what's the slope of everything to the left of my cursor? Think of the slope.
Negative.
It's negative, right? The slope is negative, right? Okay. And so right here up into that, is it going faster or going slower? It's going slower, right? It's getting lower, 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 lower right here where it's leveling out. So leveling out, what was that we said? So if it's actually getting to that point right there, I'll go back to the note because I added it to the notes where I messed up the other day. Oh, I did not add it. Open.
Good job.
4. So this is what I added to the notes. Okay, and this is why. So this is going to go down to the bottom right there. So it's decreasing at an increasing rate. And then decreasing at a decreasing rate is if it's going sharper down. So decreasing, increasing rate. So right there, so when my derivative, derivative of the derivative, which is the second derivative, is equal to 0, that's where it's actually going to change right there.
Got the right velocity equation.
Yep, that's where it's actually changing. So we're saying right there, it's changing at that number, which my second derivative equals 0. And we're going to do the derivative test, even though it's actually part of the next set of notes on this. So I have this acceleration is going to be 6t minus 18. So I factor that. So of my slopes, that's where it actually is changing concavity. Velocity of the object increasing, decreasing. So now, everything above the line in my graph So everything above the line. So from negative infinity to 1. And draw figure that velocity of the object. So here's the graph for the velocity of the object. So we know that right here, as the slope of this is going down, it's going down to right here where it's changing concavity, and then it's going to change to go this way. So the slope becomes positive at that point. So the slope of the slope becomes positive. Now, I'm going to plug in my original. I'm going to hit tab. I'm going to change this to the original function. So now let's see how well that works. At positive 1, that is a maximum because it's changing from a positive slope to a negative slope, right? Hopefully. I have a maximum right there. Okay, local maximum there. Over here, at 5, the slope is going down all the way to 5, and then it changes to go back up. So that means that's going to be a local minimum there. Where it changes concavity would be halfway in between here, and that's where I went and found my second derivative, set it equal to 0. So at 3, 1, 2, 3, it's changing from concave down to concave up. And that's what my second derivative does. Alrighty. So I'm going to leave off there. Hopefully that helps. So we will like, share, and subscribe, all that.